Hello and welcome to this week's Solution Saturday. In this video we're going to go through question 28 from the Consortium Group 2 2014 paper. Make sure to check out the other videos in the playlist for more work solutions from this paper, and subscribe so you don't miss out on any of our other videos. Consider this question. Miss Smart has a set of hexagonal spinners. Each section on a spinner contains a number between 1 and 6. Write a number in each section of the spinner so that the spinner is certain to land on a number less than 3. Keywords are really important in these types of questions. The keywords in section A are certain and less than. The word certain means that there is a 100% chance of the spinner landing on a number less than 3. And in this case, the numbers less than 3 are 1 and 2, as the spinner contains the numbers between 1 and 6. This means that the numbers you put on the spinner can be any combination of the numbers 1 and 2. You can only include one number, you can put all 2s or 1s, or do any combination you like. Now moving on to part B. The spinner is twice as likely to land on an even number as on the number 5. We can represent this ratio using the block method by allocating 1 block to number 5 and 2 blocks to any even number. You can clearly see here that the ratio is 2 to 1. There are 6 spaces on the spinner, so 3 blocks is equal to 6, meaning 1 block is equal to 6 divided by 3, which is 2. Therefore, the 5, which we have already allocated 1 block to, occupies 2 of the spaces on the spinner, and the other 4 spaces can be occupied by any combination of 2, 4, and 6. The order of this does not matter. You can include all of the numbers or just one. The probability stated in the question will not change. And finally, the spinner is equally likely to land on a square number, an even number, or an odd number. This question is slightly harder, and we need to be careful to make sure we do not make any silly errors. Let's identify the numbers that fall into each category with a Venn diagram. Here we have odd, even, and square numbers. The numbers 1, 3, and 5 all fall into the odd number category, and 2, 4, and 6 are all even. But the number 4 is both a square number and an even number, so it belongs here. We need to now consider the ratio of numbers in the spinner very carefully. If we treat the square and even numbers as separate entities as we did in the last question, and give them all equal space on the spinner, the probability will not be equally split between them. There will be a higher probability of the spinner landing on an even number than any other option. An easy way we can work around this is only including the number 4, as both our square and even option. In this way, we can dedicate half of the spinner to the number 4, covering the bases for both our square and even option. Remember, the probability of this happening is still equally likely as it occupies half of the board. And for the rest of the spinner, we can fill it with any combination of odd numbers under 6, so 1, 3, and 5. And that's it! Thank you for watching. We hope you've been able to build on your knowledge of probability. If you have any questions, don't hesitate to leave a comment or reach out on our other platforms. Check out the other videos in the playlist for more solutions on tricky questions from this paper.